All right, let's get started. So, last week we talked about selection. Any questions about that stuff? We're all good? Well, guess what? This week's just basically the same thing. So I don't have a whole lot of new things to tell you. Except maybe point out some questions that I got over the last week. But they don't really have to do a whole lot of selection. Well, they kind of do. So let's just have a look at the notes from last week and go over it real quick, review this, and see what we have for this week. Okay, so last week I told you about the relational operators, how you check to see if something is equal, greater than or equal, less than or equal, not equal, less than, greater than. Okay, and I showed you how we create conditions, right? And what are conditions? Conditions are check to see if something is true, false. And how does the computer know if something's true or false? It's part of the processor, the arithmetic logic unit can figure out basic comparison of two things. And using these conditions, we can make our programs appear to be more intelligent and make decisions. And using ifs and elses. Right, so for example, I can have something like if age is less than 0, I show a certain message. If age is greater than 123, something else shows up. So one message that, one question that kind of shows up is, let's say you have something like, let me do this, I'm going to get all this stuff out of there. Okay, so one thing that kind of comes up was like, let's say you have if age is equal to 1, right? Print age is equal to 1, all right? And then you have if age is equal to, and it's got to be double equal, is equal to 2, all right? Print age is equal to 2, okay? And then I have else print hello world, okay? So when will this one show up? When would the hello world show up? For what value of age? For what value of age will this show up?
When it's not equal to 1 or 2.
When it's not equal to what?
1 or 2.
When it's not equal to 1 or 2? All right. Let's go and so if it is not equal to 1, we're going to check this, right? If it's not equal to 2, we're going to check this. Actually, the answer is this will show up whenever this thing is not equal to, well, let's do it this way. You said whenever it's not equal to 1 or 2, right? So it's 1. So now you're saying that this is not going to show up, correct? Huh? It is going to show up. Okay, right? And that's kind of a source of confusion for some people. So let me show you. So if age is 1, right? This message is going to show up, correct? But it is not equal to 2, so this is not going to show. But since age is not equal to 2, this one will automatically show up. Okay? And if you don't believe it, hello world. Okay? So how can I make sure that this thing shows up only at, how can I make sure that, so this one, the way this right now, the above will show up when age is not equal to 2. Okay? All right. And then, so how can I make sure that, how to show the hello world when age isn't equal to 1 or 2, like you originally said. So I'm going to grab this thing, I'm going to comment it out. All right, we're going to leave it there. And I'm going to copy it. I'll paste it in there. So how do I change things so that it shows when it isn't equal to 1 or 2? What do I need to do? Hmm?
Can you use and or? No.
You don't have to use and or. What we need to do is we're just going to make it an elif. Okay? So if I make this an elif, then the above will show when the age is not equal to 1 or 2. Does that make sense? So you have an if else chain, if else chain, right? So the else shows up when everything else is false, right? Here the else shows up, or the else happens, okay, here the else happens when only the above if is false. Does that make sense? So that's a source of confusion a lot of times. Okay? So that's one thing that kind of comes up as a question quite a bit, and I wanted to show you. Another one is, and I saw this, let's see if we have it, go back. Okay, and this one comes up with the rock, paper, scissors, right? Okay, so let's look at the rock, paper, scissors problem. So let's say you have, and you remember the random number business? You have to do import, or let's do it this way, from random import randint. And I'm going to say P1 is equal to randint from 1 to 3, and then P2 is equal to input. Please enter a number between 1 to 3, right? 1 is rock, 2 is paper, 3 is scissors, right? And I go in there and I do this business. I can even make some variables. I can say, all right, well, rock is equal to 1, paper is equal to 2, scissors is equal to 3. Okay. And then what do? Let's say I have if player 1 is equal to rock and player 2 is equal to scissors, right? I say print player 1 wins, rock breaks scissors. Okay, why is this not going to work? Ever. In fact, let me just run it. So run. So you could say, well, the random number, or for, what was it? Hold on. Player 2 needed to be scissors. So let me run it again. 5. So please enter number between 1 to 3. This is for player 2. I'm gonna go with 2. Wait, scissors is 3. 3. Right? Even if I go in there and I do this, let's not do the random number. I'm gonna make this, I'm gonna fix it. It's a 1, right? So player 1 is rock, okay, and player 2 is going to be scissors. So I go 3. Doesn't work. Why is that? That's another very common question that pops up. What's the problem with this picture? Why isn't this working? Nope. Equal signs are good. P1 is 1, so it's rock. Right? P2 is scissors. Right?
P2 should be equal to 2.
Well, scissors is 3, so even if, right. That's what I entered. I entered a 3. Let's make it, yeah. So yeah. So what's the problem? No idea? Okay, so that's another one that's pretty common. All right, what happens is player 2, when you have an input, what kind of a thing is an input? P2 is actually a string, right? So you can't, right? You can't. It's basically have to compare the way you say apples to apples, right? Okay, you can't compare apple to orange, if that makes any sense. So basically, what the moral of the story is this: if you have, let's say you have if 1 is equal to 1, right? This works, yes? If you have if 1 is equal to 1, this also works. Does that give you a clue of what the issue is? This is a string input. So what you're actually doing is you're trying to do if player 2 is actually a string. So you're comparing if 1 is equal to 1. And this doesn't work. Okay, same way as if you have if 1 equals to 1, this doesn't work. Okay, so you can't compare string to int. Same thing with the other one under it. Okay, got it? So what do I need to do? How do I change it? Let me just copy this whole thing. I'm going to comment this out. Alright, I'm going to get this. So how am I going to fix it? Oops, let me erase this. What do I need to do to fix it? Int. Alright. I can also do a float. As long as it's a number. As long as it knows it's a number, we're comparing a number to number, right? So I can go in there and I say, all right, well, if 1 is equal to 1.0, right? This works, right? I can also say if 1.0 is equal to 1, right? This works. I can also do if 1.0 is equal to 1.0. This also works, right? You just can't compare. You cannot compare different data types. You cannot compare text to a number. Okay? So yeah, I could do a float. This works. Okay, so let's run it. Hopefully it works. Alright, so scissors 3. Alright. I can also make it an int. 5. Yeah. All right. Another way to fix it is, what can I do? I can just change, instead of doing this, what's another way to fix it?
You find it shrink the wall, right?
What's that?
If you find something at the shrink line.
How do I make P1 a string? So this is going to be a string, right? So if I went in there and I said, okay, this is a string. All right, try that. 3. Actually, I have to also change these. This. Run it. All right, I have a 3. That also works. Okay, so the moral of the story is, you got to compare string to string, number to number, otherwise it doesn't work. Okay, but the easiest fix will be just, make it an int, right? Because we're saying 1, 2, 3, that makes sense to be an integer. Okay, so that's one thing. And let me take this out. So that's that. Okay, so let's go back to the little thing I have in here and just grab all this stuff, put it back in there. Okay, and continue with this little review that I had for you. All right, so you have an if and elif, right? You can also have an if and else, right? That kind of stuff, right? So if I have, this is one, right? You can have, let's say if, let's say you have age is equal to -1, right? So if I have if age is less than 0, I say print age is negative, right? Then you can have an else, and this will be print age is 0 or positive. Make sense? Okay, so the basic if else, if elif, and then in addition to this, we also had the logical operators, right? Logical operators are if you have an or, okay? And let me erase this piece. Actually, I'll take this out of here. Okay, so in here earlier in the example that I was giving you last time, right? You had an if, elif, right? And basically this one is if age is less than 0, you show this is invalid age. This one is if age is greater than 123, this is an invalid age, right? And underneath it, I have an or, okay? So the or works pretty much the same way as these two. The purpose of an or is to make sure if something, to check to see if something is outside of an acceptable range of values, okay? And you have your truth table for an or, right? You basically have one condition, another condition, then an or in between of them, and the possible ways that these two conditions can be. So it can be a true true, it can be a false true, it can be a true false, it can be a false false, and this thing evaluates to true anytime one or both of them are equal to true. Okay? They're logical operators because they help you build this logic into your programs. Okay? So we already went over the if, elif, else thing in the beginning that I showed you. All right, we saw that. Then the other thing is having an end, right? So if you have one kind of an if, right? You have one if, and inside of it there's another if, okay? Then you show some kind of a message. You can rewrite this nested if, okay? And by the way, you can nest as many of them as you want inside of each other. Then you can rewrite this thing using an end, right? So if this thing is true, we go in there, right? And then if this thing is true, then we go in there. So that means that this message here is going to show up when this is true and this is true, which is exactly what the AND does, right? You have one condition, you have another condition, and you have your truth table for these. And this thing is false unless both of these things are true, okay? And the practical use of an AND is to check to see if something is within an acceptable range of values, right? We're checking to see if it's between this and this. The OR was checking to see if it's outside of this acceptable range of values. And then that's one practical application. The other practical application is just to build logic into your programs. Just, write logical statements in your software. Okay? You can have an if, elif, else. You can have an if, elif. You can have an if, else, right? Why is this here bad? Why is this bad? Hmm? It's the indent, yes. As soon as you start indenting inside of an if or whatever, you basically have to start with an if. Okay? Just the same way as if I went all the way to the top, wherever I had my first if, where was that thing? Right here, right? I can't go in there and start with an elif, right? Same way, you cannot start with an elif inside of an indentation. Okay, you have to start with an if, then you can do an else if, etc., etc. Same way, you can't start with an else, right? Why is this a problem? If and then else and then a condition. Why is that a problem? Man, you guys are on fire today. Huh? You cannot have a condition for an else, right? You cannot have, the else is not supposed to have a condition. Okay? The else automatically happens when the previous thing is false. So if I do want to have a condition, like you said, it has to be an if or it has to be an elif, one or the other. Okay?
Can you use then?
Huh?
Is there then in there or not?
No, there's no then. Yeah, there's then in like Visual Basic and some other languages, but no. It's like an implied then. Like other languages will have if, some condition, and then underneath it will be like then, and then something happens. It's just, we're assuming the then. Yeah, the then is assumed. Okay, so these are some of the common mistakes, and this stuff here that I showed you in the beginning. This one is a very common one. This one pops up quite a bit, right? Just people have an input, and they're trying to compare that input to a number, and it never works. And it's not just here. It will happen throughout the semester. So I want to make sure I emphasize it so that you get it. Okay. So what else? So these are the truth tables, and then I did some hints for you for the different assignments. Rock, paper, scissors, all that good stuff. Okay. Casting, string concatenation. This stuff is from the old stuff. All right, so I'm going to erase it. All right, that was the review from before. Okay, so that's pretty much all I wanted to tell you today. Any questions? I'm going to go and do some hints on the new assignments for this week. Not that I haven't posted those already. All right, you already have hints for those. Post it. So let's go look at it. I'll save this. Okay. So you had 6, 7, 8, 9, 10, 11, and I gave you clues on most of these, and now I kind of helped you understand why maybe the rock, paper, scissors wasn't working for you. If it wasn't. Okay, and in here I posted the hints for 13, 14, 15. I guess not the voting one. Okay, so the voting one, let's have a look at these assignments then. Okay, so this week we're just practicing selection. Okay, so the voting program goes like this. You're going to write a program to determine, let me zoom in. All right, So write a program to determine if the user can vote. The program will ask the user a series of questions about their age, citizenship, and registration. The user will receive a message as to whether or not the user can vote with a reason: too young, not a citizen, hasn't registered, that kind of stuff. Okay? So be sure to test your program at least 4 times. Why is it going to be 4 times? Because one time they can vote, one time they can't vote because they're not old enough, one time they cannot vote because they're not a citizen, one time they cannot vote because they're not registered. Okay, and what I would like to do is, for you to do, is to basically use these sample runs here that I have, right? And at the bottom I have a hint for that too, but I will go over it. Okay, so the way I would do this, zoom out. All right, so this is your P12 hint. Let's see if this works. Please enter feet. Where's that from? I'm going to take this out too. Alright, so P12, this is your hint for P12, P12 hint, okay. We're going to have the user input different things. We're going to do things like, alright, age is equal to input age, well, what is your age? Okay, and then since this is an age, it will make sense maybe make it an integer. You can make it a float too. Okay, then we're going to have a citizenship status, which is going to be, I guess, maybe something like a yes or no. Are you a citizen? All right. And then we're going to have registered is equal to input. Are you registered? Okay. So the first thing I would do is just check to see if all these different things are true. Okay. So there's different ways to do this. Some of them are more efficient than others, and that's generally speaking how it goes with programming. The better you get with it, the shorter and more elegant your code becomes. So just to give you an example, for the Java class that I teach here, there's like a graphical user interface project where I make you do a tic-tac-toe. And for the really, really good students, I tell them, all right, make it AI, all right, make it play against, make it play against you. I want you to defend. I want the program to defend. I want it to try to beat you. And if for the most students, I mean, and I've been teaching that class for like 6 years. Only 2 students have done it that way. Okay, and everybody else is basically okay. You can just make it so you play against yourself. You choose both players' choices. Okay, I had one student from Purdue who was really, really smart, right? He came in, he wrote that thing, and took him like 1,000 lines of code or something, right? It made it work, right? The program ties with you every time, and it beats you if you make a mistake. And then I had another student last semester who went and wrote the whole thing in less than 200 lines of code, right? So which one's the better one? The one with the 200 lines of code, okay? So anyway, how we're going to do this, first I'm going to do, and you can have like all kinds of multiple ifs. You can have like 9 different ifs, right? But we're going to reduce it a little bit. So we're going to say, all right, if my age is greater than, and what is this? And by the way, for every program, don't forget, copy the whole description. If I was writing a program from scratch, this is my program, right? I'm going to copy this whole thing. I'm going to paste it right on top of my code, right in there. Okay, that's it. You do that for every program. Put your name, put the date, put the Python version you're using, put the program number, and then copy paste the description underneath it. Why? Because this web page is going to shut down at the end of the semester, and if you want to look at your programs that you have written for this class, it won't make any sense if you don't have a description. Okay, if somebody else is reading your program, they're not going to make any sense of what you're doing and why you're doing it. All right. Anyway, so and then make sure it fits in, in a short little paragraph. Make sure it doesn't expand too much. Okay, remember the rule, don't exceed more than 80 characters. Sometimes you might want to break it a little bit. All right, I'm actually going over 80 characters here. Come on, where are you? All right, and then again, if you forget where the characters are, it's right here on the bottom, column 88. That means I'm at 88 characters at this point. Okay, so you must be over 18, registered, and a citizen to vote. So if you are greater than or equal to 18 and citizen is equal to yes, right? And my registered is equal to yes, right? And I guess this is a good time to show you how to make sure the user, the input of the user is not case sensitive. Okay? What if the user enters something like this? Well, let me give an example. So I'm going to say print, congratulations, you can vote. Okay? You can be part of the problem. So that's like George Carlin joke. So anyway, you can vote. So I'm going to go run the program. All right. What is your age? I'm 100. And am I a citizen? Yes. Are you registered? Yes. Doesn't show. What's the problem with this thing? Capital Y's. All right. So even if I went in there and I did something else, all right, let's try this. All right. I'm 55. I have yes. All right. And I have yes. All right. That's also not going to work, right? Because Python is case sensitive. So I'm going to do in there, and I think it's upper. I hope it's upper. Hope it doesn't mess me up. All right. So what is your age? 55. All right. Are you a citizen? Yes. Yes. Doesn't work because I forgot to, make these upper, so I can do this. Yes. Yes, like that. Let's try it again. All right. 44. Yes. Or yes, all lowercase. Yes, all lowercase. Congratulations, you can vote. Okay. You can also do lower. So citizen is going to be upper. Let's do this lower. All right. So that forces, this right here forces a string to turn itself into upper and lower case. Okay. And you can do this to any kind of a string. You can say like string. So let's say name is equal to Alex S, right? And then I say name is equal to name lower. Then I can show you print name equals name, right? And I run this thing, and now it's all lowercase. Okay, it's just a way for you to convert a string to all upper and lowercase. Okay, and you can also do name dot upper. Okay, so. And this is to convert a string to upper and lowercase. Okay? So let's do this. So registered has to be lowercase, so it's going to be like this. So now it doesn't matter what kind of an input the user enters. As long as it's a yes, doesn't matter the case, it works. Okay? So this is my congratulations, you can vote. And after that, what I'll do is I'll just say else, right? So the else will happen when this previous thing is not true. So that means if they didn't get this, that means they can't vote. Sorry, you're gonna say print. Sorry, you cannot vote, right? And then underneath it, I'm gonna have my other ifs. So if my age is less than 18, I say print. You are not old enough. All right, and then similarly, I just do all the other ones too. All right, so if I run this thing, all right, I'm 1. This is a yes. I forgot which one was supposed to be. Oh, that's supposed to be uppercase. No, it converts to upper. It doesn't matter actually. Yes, yes. All right. Sorry, you cannot vote. You're not old enough. So all we got to do is write the other two ifs. Write the other two ifs. for when the user is not citizen or registered. All right, so a couple more ifs and you're done. Okay?
Right, all the other is under else.
Yes, you would do it here, if. Yeah? Okay, so that's your hint for P12. Any questions?
It's not great.
Huh?
It's not great.
What's that?
It helps to do the more.
Yeah, it helps.
But it also says and somebody pages there. We need to do one for each of them.
Yeah, what you want to do is you're going to, well, first for the ages, you just want to make sure that one time you're going to enter something that is over 18, then one time you're going to enter something that's less than 18. So basically, go with these tests that I give you here. All right, so one is going to be, they're all good. Well, actually, hold on. Where do I have the vote? Oh, that's all the way at the bottom. So you're going to have one test when one of them is bad. You're going to have another test when two of them are bad. You're going to have one test when all three of them are bad. And then you need one more test when they're all good. All right, and if it works for all of these, you're good. Okay? So that's that. And we're going to the next one. Okay. Write a program to convert any given number of total cents under 100 into the number of quarters, dimes, nickels, and pennies, right? So you have some cashier who works at McDonald's and sucks at math. So you're trying to write the program that, you know, they type in what the customer gave them and then they're going to give them the correct change, right? They're not going to give them like 99 cents in pennies, okay? Which happens if they run out of quarters. Anyway, and dimes and nickels. So how we're going to do this? So this is P, and again, let me be a good student. I'm going to copy this thing. All right, P13. This is P13 hint. Paste this. All right, that's my description. Okay, I'm going to erase this stuff here. I don't need my hint. This is your hint. Make sure this thing fits on the same page. I'm going to break it down into separate lines. Okay, so write a program to convert any given number of total cents under 100 into the correct number of quarters, dimes, and nickels. All right, so let's do this. I go in there and I'm going to do this. So I'm going to say, all right, cents, or total cents. All right, and remember the actual naming of these variables is usually you start with lowercase. If you have multiple words, each word is separated from the other words by underscore, or you can capitalize them. Which one you use, I leave up to you. It's on you, whatever you want. Both of them are very widely used naming conventions. Okay, so this one here is going to be something like int input. Please enter the total cents. All right, and for the sake of testing my program, I don't like entering things into my programs, which is why I'm actually going to comment this whole thing out here, because I don't want to keep entering things. All right, if every time I run the program I have to go enter three things, I'm going to go crazy. So same thing, I'm going to go take this out, and I'm going to say, all right, well, let's say the user entered 66. I'm going to test it with 66, and then later on when I have fully tested my program, then I'm going to take this out. I'm going to leave it as an input. All right, but while I'm testing it, just to save myself the misery of entering numbers over and over again, I'll leave it like this. Okay, so first one is find the quarters. Okay, how am I going to find the quarters? I'm going to make a variable quarters. It's going to be equal to total cents, and it's going to be equal to total cents divided by 25. Okay, so let's see what I have. And this, what I'm doing is really how you should be doing these things in the beginning of your programming career. When you're new to things, or even in general, just show yourself what the results are. Don't just keep writing things and you're like, oh, I think this is going to work, and then you write 50 lines of code and it doesn't work, and then you have to go back to line 2 and start fixing things, and then it trickles down and you got to fix way more things than you would have, than you should if you did what I'm doing. So I'm going to just show myself my quarters. Quarters is equal to quarters. Okay, so what do you expect quarters to be for this case? 2. All right, okay, good guess. Let's see if it is. 2.64. All right, but I don't like the 0.64. You can't have a 0.64 quarters. How do I get rid of the 0.64? What's that? But how do I get rid of the decimal piece for the quarters?
Give it a percent and then period and then 0 and then F. Is that how you find that?
That actually is one way to do it. You could do that kind of stuff, but then you're gonna have to convert something to a string, round it with the percent %f, and then you're gonna have to convert it to a number, right? So yeah. So what you're saying is you're gonna do this. Quarters is equal to percent 0.0f, and then this one is going to be percent quarters, that kind of stuff.
Oh, that's a long one.
It is a long one. All right, and then you're going to have to go and say, all right, well, hold on, let me make this a float or something, or an int. All right, and then I guess you could copy this, see if it works. So this one here is 2.64. No, rounds up, no good. It was a good thought, but no, didn't work. Okay, so that's bad. But that's how you do this. You just, if you have an idea, try it out, see if it works, and if it doesn't work, oh well, let's just go back. Let me go back 2 steps now, and try another way. All right, so this didn't work. How do I round it? All right, let's do this. I'm going to say quarters is equal to int quarters. All right? So this was 2.64. How about now? Now it's a 2. Okay, so that's what I want to do. So what I'm going to do is I'm just going to say, all right, hold on. Let me just get this. I'm going to erase this piece here. In fact, I'm going to comment it out so that it's there. All right, so there you go. Now this is 2. Yes? Okay. So this is my quarters, and now I have to find my dimes. How do I do that? You said same thing as the quarters. So can I go in there and say, all right, total cents, dimes is equal to total cents divide by 10? No, why not?
It's just going to divide the same number twice.
The same number twice, so it's going to go in there and it's going to give me like 6 dimes, right? But I already had 2 quarters, and if I do 6 dimes, you're going to be losing money for the business. Okay? So, what do we need to do?
That was the carry, the 0.64
Take
down.
the number of quarters out. Okay? So I'm going to say, all right, well, I am going to say, what? Actually, I forgot to do this. This piece here, let's break it down into little pieces, right? I could just totally do this. And total cents divided by 25. Let's do that. Okay? So we said we have to subtract the quarters, right? So I'm going to say total cents is equal to total cents, its old value, minus, can I just say quarters? Why not? Because then it will do, what do you think it will do? We'll say, all right, hold on, we have the old value, 66 minus what, 2? No good. See, the computer doesn't know what a quarters is. It's just some variable, it's just some name that I made up, and it's equal to 2. So it's up to me to know that, okay, well, a quarter is 25 cents, so I have to say times 25. All right, so 2 times 25, and then this is going to be equal to what? 66 minus 50, so now I have 16 left. Okay? And then I go to the next one, Then I say, all right, now I'm dividing 16 divided by 10, right, which is going to be 1.6, unless I do an int again, okay? And then I'm going to get my number of dimes, and then you do the rest for all the other coins, right? Do the rest for the other coins, okay? And that makes sense for so far. Whoops, total sense. Okay, quarters, I forgot to show me the dimes. Print dimes equals dimes, run again. All right, so far so good. Okay, works beautiful so far. But this is assuming that the user entered 66, okay? And what you should try to do is you should try to break your program, all right? What if the user doesn't enter 66? What if the user enters 16? What if there's no quarters? Now what? Run it. Quarters 0, okay, sure. Well, why don't I just get rid of the quarters? If I don't have any quarters, I don't want to show the quarters. Okay? So what I can do is I can say, all right, hold on. This looks good, but I can improve it by just saying, okay, if my total sense is greater than what value do I want to do this? 25, right? So only if it's 25 or more do we want to do any kind of calculation for quarters. Oops. Damn it. Tab it. Okay, does that make sense? And I guess this piece here should only be done inside there, because I only want to do this calculation if there is any quarters. If there isn't enough total sense for me to calculate quarters, I don't have to be subtracting quarters at all. Okay? Make sense? So same thing I have to do for my dimes. So if total sense is greater than or equal to what value? 10. Right? That's when I do this. Yes? And then I have to subtract it. So I'm going to say, all right, total sense is equal to total sense minus dimes times 10. Okay? And this also can be rewritten as total sense minus equals dimes times 10. So this here is the shorthand notation. All right? Shorter. But it does the same thing. Okay? Same. All right? And you're going to do the same thing for your nickels and for your pennies. And that's it. Any questions? Okay. So now that the program is fully tested, then you go back in there and you take, of course, you're going to does it work for 16? Yeah, sure, great. Then we're going to go and we're going to test it. Does it work for 6? Sure. Make sure that we don't see 0 quarters and 0 dimes. So first of all, let's check to see if this worked. Right? Run it. And running your program and testing it frequently is the key to success. Right? So write like 3 to 5 lines of code. Check. Go down. If it works, write another 3 to 5 lines of code. Check again. Okay, if it doesn't work, fix, just like we did. Okay, so that's the deal with this. And when it's all done, so when it's done with this, then you're going to go and check it with 6, right, to make sure that it works only for pennies, right? So then you're going to go and check it for something like pennies, nickels, to check to see if it works for pennies only, right? When it's all good, go back to like maybe 66, make sure it works, and then do this, right? And then that's it. Okay? It also makes sense maybe to check to see if the user doesn't enter a negative number or something like that. But let's not go there. Okay? So there you go. That's this. So I'm going to comment this piece out because I don't want to be looking at it. I guess I'll leave it. Okay, so that's your P13. All right, and now I'll take it out. So the next thing is I am going to look at number 14, which is the astrology program. All right, and you're basically given all these different zodiac signs. All right, and you're supposed to ask the user, so this is P14 hint. P14 hint. All right, so these are my zodiac signs. You're going to ask the user, all right, ask the user for their birthday and tell them what their sign is, basically. Okay? And then last semester or during the summer, I can't remember what it was, but it was during the summer. All right? One student came up and told me, this problem offends me. Because of consciousness issues. Man, I almost snapped. I was like, all right, I counted to a million, then I came back to him. I'm like, look, buddy, use fruits and vegetables then. Okay, use the same dates, but use fruits and vegetables instead of these constellations, if that makes you happy. So he did. All right, we have a program with fruits and vegetables written somewhere. So, because it offends somebody about ram and bull and twins and crab, all right? So anyway, if you're one of those, do that. So what am I going to do? I'm going to ask the user for their birthday, so I'm going to have day is equal to input. Please enter your date of birth. All right, and then you can say month is equal to same thing, and input. Please enter your month. All right, and then just like before, just like I did up here, I don't want to go and type in numbers every time. For testing purposes, I'm just going to take these out. And I'm going to go with one of these here. All right. Let me line it up because I can't stand it. There you go. I don't know why it does that. I'll leave it there. Okay, so let's go. I'm going to go test this one. All right, so we want to do Aries. Okay, so I am testing this one. Okay, and of course you're going to have to do it for all the other ones, but I'll show you how to do it for the first one. Okay, so what is an acceptable value for Aries? What birthday does the user need to have? Give me something. What month? March. Okay, so let's say March is 3. Okay, and then what date? 22nd. Okay, so that would be an Aries, right? Now I have to write my ifs, and this is an exercise with ifs and else's and ors and ands and that kind of stuff. So I'm going to go and say, all right, if let me put this under. And it really is good for you to just put comments in there so that you know exactly what you're doing as you're doing it. So how am I going to construct my if? If month is equal to what? March, right? And my day is greater than what value? Greater or equal? 21. And then I guess if you really want to be very picky, you can go and check, all right, hold on. How many days are in March? All right? March got 31 days. Okay, go to March, 31 days. Then I can go and say, all right, and day is less than or equal to 31. Make sense? If that is the case, then I'm going to give the message print you are Aries, right? And I suppose you can do the same thing for the other one. You can do another if. If my month is equal to 4 and my day is what? Okay, good. greater than or equal to 1, because we want to, we want a valid one, and day is what?
Less or equal to 19.
Less than or equal to 19. Then I give them this message again. Okay? So that's one way to do it, okay, which is totally fine. And again, you should test it. All right, let's test this thing, run it. I should get an Aries. There you go. Okay, let me change the date or the month first, 4, and let's go with day of like 5. All right, that should also give me Aries. Oops, days. All right, that's why you want to test it, because you never know. All right, see, it looks like I wrote everything the same way, but I didn't. There's an S in there. That's why you want to check every possible outcome that your program can have, to make sure there's no bugs, so that you don't ship it to your customers with bugs and it backfires in your face. So that's one way to do it. Another way to do this is to use an OR. Alright, so I'm just going to say, alright, hold on, get this, that. I'm going to put parentheses around the whole thing. And I'm going to say OR, and then this whole thing. Alright, I kind of broke my rule. I went over 86 lines, but whatever. Okay. Oops, what's happening? Okay, I go in there. Okay, and then I give you this message. Okay? Make sense? So do the same. And again, you want to check it. Of course, it should work. I already just checked it. But you should check it again. So I'll do this. Do this for the rest of the zodiac signs. Okay, and the way I would do it is I would do an if, elif, and then the final one will be like an else, right? What would the else be? Something like invalid date or whatever. You entered invalid date, maybe. Okay. Make sense? There you go. So that's 14. Next one is 15. Let's see how many more I have left. Week 3. Yeah, that's the last one. 15. Sum of positive and negative numbers. Okay. And let's have a look at this thing here. So this is P15. P15 hint. Okay. So first of all, I would like to point out to you that in this class, you are not allowed to use any built-in Python functions. Okay. I teach this class also at MPC, which is a little bit ahead of this one. They're like a week ahead, which kind of gives me, that's why I know what questions are coming up. And one student, what that student did was, the student thought about this long and hard, and they figured out, all right, hold on, what I'm going to do is I'm going to enter these things into a list, and then I'm going to use the sum Python function to sum the things for me. No, you don't get to use anything that you haven't written yourself, right? So you don't get to use any built-in Python functions other than, I guess, print, int, float, input, and then range. Oh, and randint. That's it. Anything else you find yourself using, I'm gonna get the axe and like cut points off. Okay, so none of these, because Python has so many built-in functions. It can do something. It can sum. It can sort. It can find min. It can find max. It can do all kinds of things for you. But if you're just using these built-in functions, do you know how they work? No, you're just using somebody's code. You're basically plagiarizing. Okay, so don't do that. So what I want you to do is, this is basically an introduction to accumulation, right? So let's say you have some kind of a num, right? Num is equal to 0. Okay, so I guess let me put a little label here. All right, we call this accumulation. Okay, so accumulation, what is accumulation? Right, a variable increasing its own value. Okay, so num is equal to 0 if I say, and we kind of saw this maybe earlier when we're doing this stuff here. We had a variable decrease its own value, right? Same here. Okay, so I guess that's like I don't know what you call accumulation in reverse. All right, so this is num. So I want to increase num by +1, right? I'm going to say num is equal to num +1. So increase the value of num, or the old value of num, by 1. Okay? I can also do it this way, plus equals 1. Right? That's the same thing. All right? If I want to increase it by 10, I do num is equal to num plus 10. Right? By the way, so num is equal to 0 here. It's equal to 1 here. So num equals 1 here. Here num is equal to, now it's going to be equal to 2. Right? When I do this, right? Yeah, I basically have, what I'm actually saying is I'm telling it, you are equal to your old value plus 10. What's the old value? Well, whatever it was on the previous line, which is a 2. So it's equal to 2 plus 10, which is equal to 12. All right? So here num is equal to 0 plus 1, which is 1. Here it's equal to 1 plus 1, which is 2. Here is this, right? And there's also a shorthand notation. Let's say I want to say num plus equals 20, right? What is it equal to now? 12. Num is equal to 12 plus 20, which is equal to 32. Make sense? So, and the same thing goes in reverse too, just like we saw up there. Okay, let's say I want to decrease. Oh, by the way, one thing to point out. Notice when I hit the enter key here, the indentation is kind of messed up. That is an indicator that I did something wrong. So what did I do wrong with this line? What's wrong with this picture? Yes, I can't do this. Right? If you ever hit an enter and your indentation does not appear to be lined up where you expect it to, like it should go here. But when I have the colon, when I have some kind of a syntax error, Python will start messing up the indentation, kind of to tell you, hey, look, you messed up something. Okay, so that's that. Another one is like, let's say we want to decrease the value of num by 1, right? Want to decrease the value of num by 1. I go, all right, num is equal to num minus 1. So what is it going to be equal to now? Its old value minus 1, which is now 31, right? If I want to, I can do num minus equals 1, right? So now it's going to be equal to its old value. So num is equal to 31 minus 1, which is 30, right? If I wanted to do it by minus 10, I do num minus 10, all right? So now it's equal to, num is equal to 30 minus 10, right, which is 20, right? Then I can do num minus equals 5, right? So now it's equal to num equals its old value minus 5, which is 15, right? So that's accumulation and decreasing a variable by some value. And we're going to take advantage of this kind of a business. Okay, so let's see the assignment real quick. So write a program that asks the user to enter 4 numbers, positive or negative, and then you're going to show the sum of these, all of them, some of the positive only and some of the negative only. Okay, so I'm going to do sum of, let's go with positive. Okay, so I'm going to do something like this. I'm going to have a is equal to int, do I say in integers or anything? No, float. Let's go float. Float, enter number 1, right? And I will do the same thing for the other ones. All right, so I'm gonna get this, paste, paste, paste. This is gonna be B, C, D, 2, 3, 4. Right? Okay, so then I go in there, and just like I've been doing before, I hate typing things into my programs. I'm just going to take this out. Take out, take out, take out, because I don't want to type stuff in. So I'm going to go like 1, -1, 2, 3. There you go. Okay? So first, how do I find my sum? Sum is equal to 0, right? Remember, if I wanna keep adding values to something, I should start. If I'm trying to keep track of the sum, start it at 0, right? If I started at some other number, it's not going to be the sum of all the things. Okay, it'll be the sum of all the things plus this, right? So I go in there and say, all right, well, sum of all. Let's call it sum all. Sum all. Okay, and then I do sum all is equal to just basically A plus B plus C plus D. That's it. All right? That makes sense. Okay? But how am I going to do the sum of the negatives? Okay, I'm going to start it at 0. Then what? If. Excellent. So if A is less than 0, then sum neg is equal to sum neg plus 8, right? Only add it if it's a negative number. So only add it to sum neg if it is a negative number. Okay? And I'm going to do the same for the other ones. If B is less than 0, right, I'm going to say sum neg plus equals B. Okay? If C is less than 0, sum neg plus equals C. And then if D is less than 0, sum neg is equal to its old value plus whatever this thing is. Okay? And to test, let's check. Print sum all equals sum all, and then sum neg equals sum neg. Okay? So, run it. And sum of all is 5. 2 and 3 is a 5. These two cancel each other. Sum neg is a -1. Yeah, that's it. All right? And then again, you can go in there and play with all these different numbers, change them around, that kind of stuff. Okay? So now you got to do this. Find the sum of the positive numbers only. All right? You do this. Any questions? We're good? Awesome. Okay, so that's what I have for today. I will post this for you and for your viewing pleasure and your watching pleasure. I have a video